Well, thank you very much, everyone, for coming here. And it's delightful to be back in person with you guys. And I will encourage anyone in the audience to ask questions as we're going through this. My name is Kate Stewart. I've been with the Linux Foundation for about 6 years now, and I've been pretty much with the Zephyr project since the start of it. And one of the things that I've been focusing on the last few years is for embedded systems, how do we get them dependable? And that part of that is also how do we get security into them? And this actually is a fairly recent stat. It was just put out by that group right down there. I can't read it in my own screen, but the Statista folks basically had it out and had it available. And as you can see, there's over 10 million IoT devices out there right now. Based on the world counts from the UN and so forth, I think there's something like 7.8 or 7.9 billion people. So there's now more IoT devices out there than there are people on this planet. Okay, the scale is enormous. And as you can see from the projections, you know, these IoT devices are sensors. They're tiny, they're small. They give us data, they give us useful data. They let us optimize energy, they let us optimize things. However, we need to make sure these things stay secure. You know, the various other analysis that's happened out of industry in the last year has identified places where they see the biggest share of security issues coming in. Medical, obviously, energy, you know, safety critical, security cameras, printers, consumer electronics, and so forth. All of these are risk areas, and it really doesn't even touch the whole spectrum that I think is out there for us to work with. And key here is all of these resource-constrained endpoints have the potential to feed bad data and hacks and various security threats into our ecosystem. So we need to figure out how we can secure this stuff better. And, you know, a large number of, you know, the 98% of the traffic on IoT is unencrypted. So we don't even have the encryption sitting there today. So, you know, yes, you may not matter, you know, if your heart rate stuff is going in, but maybe you might actually at certain points in time not want people to know your activities and your heart rate. Thank you very much. There's been a couple of interesting work into it. Reduced activities based on, you know, how people react and stuff like that. We've got a lot of personal data that we're putting out in these sensors. And we need to figure out how we can make sure that we actually start to trust this whole ecosystem. So recognizing this in the last couple of years. In Europe, the folks have, you know, guidelines for security and other things. Last year here in the US, and probably the IoT Cybersecurity Improvement Act that got passed. So governments and industry have opened up and actually to IoT. There's no joke that we have around. And the joke is obviously that we do with IoT. The first to be effective as that scaling is going to happen. So for those who aren't familiar with IoT, it describes the physical objects that are embedded, the sensors, processing ability, software, and other technologies. So it's pretty broad and pretty wide, is following one of the description of IoT. It could be an edge, it could be a server, you know, it could be like, you know, a little pulse, you know, sensor on my that is measuring the temperature in a room. All of these things have various levels of software behind them and various connectivity. And the connectivity is what's making it an internet of things. So in my mind, I'm pretty much breaking it down to two classes here. I'm breaking it into the class of devices that are Linux on them, at which point we have all the Linux security stuff to draw off of. We have the encryption. We have a whole rather rich ecosystem. And then we have what I consider resource constrained, where Linux just won't fit. Linux doesn't get much smaller right now than 2 meg, okay, for an image. On those sensors and actuators that cost, you know, fractions of a cent, they're not going to be putting enough memory onto those things to work. Now, if you can run Linux, do it, okay? But we need to basically come together on those, you know, light bulbs effectively, and, you know, the temperature sensors and the motion detector stuff, and be able to have secure information being transmitted. So this is the big question. How do we have that security when we're using these resource-constrained devices? Well, this was one of the challenges we took on with Zephyr 5 years ago. We actually designed it because we knew we wanted to go after safety certifications and security certifications right from 5 years ago. And just quick show of hands in the room here. How many actually have heard of Zephyr before this meeting? Okay, I've got some people to talk to. Thank you, guys. So I'll give a couple minutes on it then. Zephyr is a real-time operating system. Okay, there's a lot of other RTOSs out there, and this was part of the problem. A lot of people were doing these things in the sensors and actuator space in bare metal. And then we had various fragmented communities, and we had various fragmented proprietary stories around these devices. And what we needed to do was to figure out, okay, how can we actually get critical mass to work on some of these problems together? And so we started Zephyr project off with the goal that we would be eventually tackling that safety and security story. It is multiple architectures. It has vendor neutral governance. There is no one company in charge of this project, okay? And that has been something we have strategically worked towards, actually, in the sense that some of the initial founding companies are still very active in it and are contributing actively to it, but their proportion of contribution has gone down. So if we start looking at metrics and life cycle and of projects, the Zephyr project is actually has had very good growth, and they're probably the founding companies are contributing more now, and there's a much smaller percentage. The project's permissively licensed. That was a decision that the founders made. It's Apache 2. And it's very modular. Everything you just compile in what you need. You just build in what you need. That's the heart of it. So those who are familiar with Linux, it's using kconfig as well. So while it's not Linux, it's a completely different code base from Linux. It uses some of the same tooling effectively underneath the covers to let you choose what you want to bring in. So kconfig is being used there. And it's also using device tree. So all those devices that you're working with, talking to the things, they could be writing with Linux too, and they could be using the same device tree images. So those who are familiar with that, the embedded Linux environment have found a very easy transition into Zephyr, and we see a lot of them in the Zephyr community today. It's there's actually products out there in the marketplace with it now, and we just actually over the weekend put out our second LTS. So that's our long-term stable. I'll go more into that later. But what we've been doing is we put our first LTS 2.5 years ago, and we've been putting in updates and security fixes to it. Because one of the challenges that we saw when we started this is, most people don't want to keep up with the tip, okay? To give you a bit of context, in the Zephyr repo right now, and I'll show you the stats live after I go through the bulk of the talk if you're curious. But to go through the Zephyr repo, you're looking at about 2 commits an hour now. To give you some context, the Linux kernel is about 10 commits an hour. So we're working at about 1/5 of the speed of the Linux kernel in terms of the commits and interaction and pull requests. And there's well over 1,000 developers now participating in Zephyr. So it's gotten a fair amount of momentum over these last 5 years. And we're sort of just starting into actually getting it ready for a safety certification now too. And so moving over to using things like MISRA coding standards and going after some of these things so we can actually go after that next level of quality and provability, and quite frankly, making sure that it stays in shape. So today, we've got all of these architectures supported in Zephyr. And when it started, there was the M core from ARM, the x86 from Intel, and we had the ARC cores from Synopsys. Those were our 3 starting points. And since then, we've expanded out to this full set of architectures. And like Linux, these architectures can all build on these other components that are out there. And so it makes it easy for you to mix and match and switch and not be locked into a specific hardware architecture, and I'll talk to you a bit later, be locked into a specific cloud. And these are the things we're sort of working on with Zephyr, because we need this for the security side. As you can see, the architecture is pretty complete at this point in time. There's a few more technologies I'd like to see added in here. Actually, let's see. We'll use the mouse here. We do have a lot of common communication technologies already working and proven into the ecosystem. So this gives us ways of talking up to higher level protocols and systems. Like I say, Zephyr is designed literally for the edge points, like the device constrained edge points. It can be used for other things if you bring things in, and it's the size of your image is going to be very much what you decide to put into it. But these are all building blocks you can pull in to solve your problems. And we've recently added in the CAN stuff for the industrial, and it probably has one of the best Bluetooth low energy stacks out there right now. In fact, we've been working with the Bluetooth SIG for the last couple of years, and they prove out some of the technologies in there. So there's mesh stuff, there's the low energy, the audio stuff is coming out. There's the open thread technologies in there. And this, all of the code for this is visible and apparent in our repo. Some of our members and others have SDKs that have additional technologies that they've made available with Zephyr from their specific viewpoint. But these are the things that are there and open today and available for use, just to choose. So the other thing that Zephyr has got at this point now is we have over 350 boards in the repo. So if you've got a small board that's being used as a development board and something like that, there's a pretty good chance you'll find a Zephyr starting point for you if you want to start playing with your application. And if there isn't, there might be something close that you can just adjust, and then please upstream it so that others can build off it. This is why open source works. But these technologies are there, and they're, these boards are there that people have contributed, and companies have contributed, and hobbyists have contributed. It's, it's got a pretty wide ecosystem at this point of people participating from different roles and different interests. Now, that 2 commits an hour is what's happening in development. That makes it hard for people making products. That makes it hard for people who need to keep things stable and don't want to see changes, don't want to have to go back and recertify partitions too often, things like that. So what we've done is every 2.5 years, we're cutting a long-term stable release, and that's what just happened last weekend. And from that, we're taking a subset, and this is what we're starting in on now. And we're taking it through the processes for requirements and traceability from the view model for going after some of the safety certification. And so going for the full test coverage, going for the code coverage aspects, and mapping back to the requirements, and then documenting it. And so this is one of the things that the safety team is starting now, that we've gotten our second LTS out, and the code base is close. We've got a few more MISRA changes we'll be pushing through to align with the MISRA standard. There's work ongoing there. But anything that we do into Audible, or quite frankly, into long-term stable, goes back to development. But for the most part, it's upstream first in development, and we move it into the others. So that's kind of our flow. We're sort of, taking the lessons from the Linux kernel. Open source works by building on what other people have done before. We saw a model that worked there, and we've adopted it. Now, in Zephyr, we've also found some other things that we've changed up. We have a different type of cadence than the kernel does, but that's working for this community. So the long-term stable, like I say, it just came out on the 17th. Yeah, 17th on Sunday. It's product focused. It's going to be kept stable, current with the latest security updates, compatible with new hardware. So if you want to basically build an LTS version, you can see all the pieces to pull together. And we've got, we had a very long testing cycle, and we had various quality metrics in terms of the open bugs that we knew about in the project that we had to get down below before we could release. So there was, we pretty much say, we've got the SEVs, the high severities, and then the, mediums, and then the lower ones, and we had to basically squeeze down our lower ones. We had too much of a backlog, and so we're keeping a pretty close eye on the bugs and what's left outstanding when we put these releases out. It's not feature-based, it's not cutting edge, but if the features you need are there today, recommendation is probably to start with an LTS for a product. And over the last couple of years, we put out updates releases. Oh, interesting. Not sure why that's doing, but okay. And so, there's been regular maintenance releases that have been put out, and you'll see the CVEs numbers sitting there for the security fixes, so that we have a reasonably good starting point for people. And there's a bit more information there. The other thing we're doing with this, as you saw, is that little auditable. And the security committee and safety committee determines what's there. And that's going to be kept in sync as we're going forward with the LTS. So the project itself is, like I say, we started this off with the view that we're going after security. So back in 2016, we started a security committee, and this is met bi-weekly every week for the last 5 years, 5 or 6 years. We've had a very early focus on leveraging the automation for break regressions. There's been like check patch. There's been a variety of processes, checks that basically happen on build, well, before the build starts. So we put a commit in, and you can't merge it until we've got all the checks clear. Multiple people have signed off on it, is what's happening now. So we've got that multiple sign off, and we're working with Parasoft, which is a member of the project, to get their scanners incorporated in for MISRA. So as soon as we have the MISRA compliance there, quite frankly, you're not going to be able to check something in that's going to break it. So we have to get ourselves up to a good level for the start, and then we want to keep it that way. Standard theorem proving, right? You build your base case and you build your iterative case, and then hopefully you're good from there on. But yeah, we're trying to make sure that we can do that. The secure coding practices is one of the first things we looked at. And we've been documented publicly for the project. Those links are in the slides. You can go and look there. And then we started actually looking at, okay, we need to start handling our own vulnerabilities. There's not a lot of open source projects out there that are actually their own CNAs or CVE numbering authorities and handling their vulnerabilities. And that's something we actually took on as a project. And the security team, some volunteers from that team became our PCERT team, or security incident response team. And they're the ones who basically, we've got a private communication channel into them to let us know when there is a vulnerability. And then we do responsible disclosure practices. And we actually worked with MITRE back in 2017 to make sure that we actually could follow what they wanted us to do. The other thing we've been doing as a project, I'll go into more of these in detail, is going after the best practices. It's now under OpenSSF at the Linux Foundation, but there's a core infrastructure initiative that about 5 years ago started off with a set of best practices for open source projects for working in security. And we started this off with Zephyr because it was starting about the same time as Zephyr. So we figured, okay, let's try it. So we eventually got to passing with Zephyr, and then we stopped passing. What's going on here? Well, we stopped passing because they actually had enough automated checks that they could tell our infrastructure changed. So we'd moved over from Jira onto GitHub for some things, and it started failing us. Okay, at that point in time, when they started failing us, I actually started taking it seriously. There actually got some stuff in there that is important for us to build from. So they introduced in 2016, 2017, somewhere in that range, silver and gold levels. So there's some baseline passing practices, and then there was the higher level ones. And as a project, we strategically decided in the security team to go after the highest level. And so the nice thing about this, and again, as we hit the end, I'll show you where you can go look at this yourself. And if you disagree with anything we've said, we want to know and we want to fix it. Because again, more eyes makes the higher quality in my mind. And then we also have our vulnerability response criteria published, and we manage by the PCERT teams so that we can actually, people have products and they want to register with us. As long as they publicly refer to the fact that there's a Zephyr project and there's something that's, someone can order, we'll put them into our embargo window and tell them, give them 60 days notice before things become public. But this is all part of, we need to basically improve this token structure. So first thing was that security documentation. We had people from various other PCERT organizations, and XP in particular was a large leader in the early days on this. And then Lenaro, some people at Lenaro joined us, and they'd had backgrounds from Qualcomm and other large organizations. And so they were familiar with the security development and design practices, and we've documented it, and it's up on our website in our public docs. We also looked at what was happening with other open source projects, what other things we could learn, can we build it up? And we did when we found it, and we're always continuing to look because things keep evolving in different places. And so how we bring this in, all of security is not an end destination, it's a journey here. And we have to keep on reinforcing and revisiting and improving. And most of the people in the Zephyr security team believe this as well. So we're sort of going, we keep going for it. But if you're curious, the Zephyr public site has the documentation and you can look at that. Now, part of working with Zephyr is we need to have secure boot, secure updates, and I'll go into a little bit more because that's part of talking to the cloud and Linuxes and other things. But we do have there's a bootloader that we sort of standardized on using, MCU boot. It does let us use trusted firmware, and it does let us do signed images with revertible upgrades. And that's been working fairly well for the Zephyr project. We've been looking at Suit and a few other options in future to make sure that Zephyr talks well with them. These are, as people want to volunteer and work on it, like I say, it's an open source project. There's no, it's when people have interest, things move forward. Zephyr does support a variety of crypto drivers, both hardware and software. There's 3 of them that I'm aware of right now that are hardware accelerators, but it's using the same API. So you can transition between software and hardware as you need to. And then we're using the embed TLS as well as TinyCrypt. Now, one of the things I'll be completely transparent about is, the people who started TinyCrypt are sort of not as active in it anymore. And we're looking for people to start maintaining it. And we may or may not bring it into the project to keep it maintained because it is very lightweight and we need to have that encryption paths in a very lightweight fashion. So these are things that the project considers and it's continuing to, monitor. The other thing we're looking at is, keeping an eye on our randomness. And that's as initially, that was tending to be where we were finding the vulnerabilities getting reported against us initially. So looking for options for randomness and improving the APIs is something that we're sort of working on towards. And if people are interested in that topic area, certainly have welcome input. Now, I was talking a little bit about the CVE numbering authority side of things with MITRE. Most of the people that are on CVE numbering authorities are either government organizations or companies. I think there's about less than a handful of projects and we're one of them. And I think more open source projects should be managing these things themselves. I think Kubernetes is there and a couple of other large ones. But we've, as people were reaching out to us, we wanted to basically be able to make sure we could handle it properly. And so we went through our processes, we documented it, and we set up this committee. And we've been CNA there since 2017. So we've been there now for 4 years, managing vulnerabilities. And it gave me a really interesting insight into more of the other security stuff that's been going on. And, I've taken it back to the team and some of the others were attending and interested. So being part of that larger security window, this was my window into becoming more aware of security issues, but because of the MITRE organization and the CVE organizations. Because before that, I really didn't have much. I've come in from the open source side and the licensing and other interesting points of view. So I was talking a minute or two ago about the badge. This is the logo, and you can see that Zephyr's been a gold badge now for a while. This project has moved under the OpenSSF framework that just got announced as a foundation. But its repos have been up on GitHub. We've had our gold badge for the last 2 years since 2019. And it took us about a year to get that last part of it. We had to, we actually had to create an app so we could demonstrate something in order to get the badge for some of the things it was looking at. But there's about, I think we were the 5th one to get our badge. We actually got the badge. Zephyr got the badge before Linux did. Okay, so it was something that we were happy with as a team. But don't get me wrong, Linux is I work on a lot of Linux stuff too, and I'm a large fan there too. And I'm glad that both the projects are there. But only 10 have achieved the gold badge status right now. I think there's about 5 or 6 that are in the silver category right now, and the rest are mostly passing or working towards getting passing. So projects that are interested in having taking security seriously, I'd encourage as a metric to be looking to see what state they are with their badging, if they've even tried. I think then if they haven't tried, to encourage them to do so. The chaos metrics are using the badging as part of a risk metric and what levels of badging people have, because it proxies a lot of other information. As you can sort of see, it's proxying the basics, change control, reporting, quality, security, and analysis. And you basically are asserting on behalf of your project what your practices are publicly. And I think this is a best practice, quite frankly, that all projects should be able to do. They should be able to talk about what they're doing and be willing to take feedback and willing to try to improve for always adopting these best practices. The other thing, these vulnerabilities and handling vulnerabilities, which is part of what the PSERT team does. And we actually, in 2020, we actually received our first bulk vulnerability report. Up to that point, it had been like, a couple of quarter, one or two a quarter, continually since we sort of started having things set up. But all of a sudden there was 26 vulnerabilities sitting there for between Zephyr and MCU boot, somewhere in MCU boot as well, part of that thing. And so it basically made us relook at our processes in this area. And, our basic process is, the issue comes in, we assign a CVE to it, we figure out which maintainers need to work on it with the PSERT team, and then we do the embargo determination. And then at the end of it, once, we've hit our window, time window, we basically disclose. Well, we need to look at it a little bit differently. So that security report in 2020 had critical, high, medium issues, and we put them into our JIRA system, which we actually are changing from now. So I'm waiting to see whether or not our badge is going to need to get adjusted further. But we just finished moving over to GitHub Issues because they've got enough security on them now, and it ties in better with the workflow from the developer perspective. A lot of these, most of the decisions, in fact, of Zephyr are determined by the developers. It's very much a developer-driven project, and it's sort of, what they care about. So these were applied in, these were fixed in the embargo window. We applied them into our main tree as they came in. The prior release, which is what we committed to support. So it's main and prior. So it's TIP and prior, current active one, so to speak, and then the LTS one. And most of them were, most of the things that they got reported with issues became one or more CVEs. And then once the embargo was passed, we pretty much created the updates, and it's now in a vulnerability report if people want to look at. We keep our vulnerability reports online too. And working with NCC group, they basically in the reports had most of their issues were fixed in reasonable time and included in the release. So they were pretty happy to work with us and have been pretty complimentary since then. We did decide to increase our embargo period though from 60 to 90 days because we recognized that the product makers wanted to have 60 days to work on these things. Since we're an OS and we're a component that they're incorporating, we needed to give them some more time. And we also set up a vulnerability alert, so you could register to notify. So we actually have free notification service. So these things are there, and we continue to improve our processes. And the .2 maintenance release basically incorporated the fixes for that one. So that vulnerability alert registry is, it's one thing to have it on embargo, but you got to be able to notify someone. Now, open source projects have this really interesting challenge. You don't know who's using them. No clue. You get little traces here and there on social media. You get little traces here and there on Slack, and now it's Discord channel for us. However, we're seeing, I'll pull up, the numbers later, but we're seeing all sorts of downloads happening, in the thousands a day type of range. And there's people using the repo, there's people contributing in. The estimate is probably about 10 people are using it for any one person that contributes upstream. That's the rough heuristic I've been using. And I don't know if anyone knows a better one, but that's as close as we can come. But the fact that we see traces of products now showing up, we see traces of these other things. These things are all very subtle. And we just needed a way of being able to let people know if they wanted to be notified, they could be, because we felt that was a responsible thing to do from a security perspective. Now, one of the things that our security team did have to deal with last year is when Amnesia 33 came out. Well, for those who are not familiar with Amnesia 33, it's based off of the FNet. Some of the people determine some vulnerabilities in the FNet stack. Now, FNet is used pretty widely in the IoT space in a large number of projects. However, so we pretty quickly determined that our current main tip in the 2.0, I think it was 2.6 at the time, 2.5, 2.6 at the time, wasn't affected because that code wasn't there from FNet in our repo, and they did a cross-check. However, there was some FNet code in our 1.14 release, which was that last LTS. However, we actually went down to the source file level and verified that no, the actual files that had the vulnerability from those stacks weren't in our code base. But we had no way to signal it. And so this is why there's work going on in a project from Oasis called CSAP for Security Advisory Frameworks to start to automate all this stuff. And this is something we're obviously tracking pretty closely from the Zephyr perspective, because we could have used that. We had to do a blog post. That was the only way we could tell people that they weren't affected. And we were getting queries. Okay, hey, yeah, no, you're fine, type of things. But we had to be able to publicly signal that in some way. And so that's what's going on there. And so we're continuing to improve our vulnerability tracking. We see these things with our multiple RTOSs. We didn't initially make the list of ones that they notified up front and reached out up front. We're sort of, making sure we stay engaged. And then we have our security advisories page on GitHub as we are working this stuff forward. Now, one of the things that happened in this earlier this year in May, is there was the awareness was growing about we've got issues at the nation's cybersecurity. And the executive order came out in May about how do we improve cybersecurity. And one of the things that I found was very interesting, and obviously, is the call for providing the purchaser of software, a software bill of materials for each project directly or by publishing it on a public website. Well, one of the things that was kind of nice from my perspective is we've been working towards being able to publish Sbombs already in Zephyr. With the 2.5 release, we could do it at the source code level for each release. And then starting with 2.6, during the build, you can now generate out software bill of materials with Zephyr automatically. You just say West SPDX and you'll get it. And to understand Zephyr is C code. So if someone tells you you can't generate Sbombs for C code, this is a counterproof, counter example here. It's perfectly possible. We can do it today. And we've actually did it. We had a bit of a doc fest in the SPDX community a couple months ago. It was in September now, so yeah. And one of the things we were looking at was the Libra Solar project, which has the Libra Solar project's really cool from my perspective anyhow, in that it sets up microgrids. And so it goes between your solar panel and a microgrid within your community, like a local community. Been deployed in Africa, interesting in the energy sector, specifically because it's all open source. So we have a system sitting there. And it actually was based on Zephyr for part of it. It's also based on some open hardware, which is also another reason that's really cool from my perspective. And you're able to generate out Sbombs for the entire system using, when you're doing your builds for Zephyr, for creating your binary image that when you deploy on your hardware. And there was a town hall in August that we had on the 18th. And if you're curious about this type of thing, I'd say check out Steve Winslow's talk. Because what it's doing is it's not just generating one Sbomb, realistically it's generating 4. Now you can stitch them all together into one big Sbomb if you want. But there's a source bomb for the Zephyr project source files that made it into the image, one for the SDK, one for the app. And then for all the built images, there's a 4th Sbomb that links all of those binaries into which libraries they've made as intermediates, and then the final ELF file. But from that, you can trace it all the way back to all the source files, which, as you can see, for things like Amnesia 33, you need to be able to do to know that you are not impacted. And so we suddenly have the ability to really be very precise about exactly everything that is there and have that transparency that we're going to need for dealing with security at scale. So that's kind of why I consider it sort of a best practice out there. Now, another thing we need to do is make sure that, as we communicate, and you bring up things, can you do it securely? So we had our first ever Zephyr Developer Summit in June this year, and it was very successful. And the talks from this summit, it was free to attend, and the talks from it are all free and up on YouTube now. And so we've got the link to there. But we had 2 talks about securing, MCU boot 5 minutes or less. Jared Wolf did some awesome, he did some awesome work for the on the project, and he's got his own consulting company, and he's sort of in there active and showing people how to do things, which are things that are there today. So using the manager for doing the field over the air updates and doing it in a secure fashion. He's got a good talk there for about 20 minutes or so. And then, the trusted firmware infrastructure is all in place with Zephyr today as well. And there's more things coming. So there's paths for doing that secure boot and establishing the trust with the graphically signed keys and so forth. Then there's also the whole, how do you provision a whole fleet of devices and how do you talk to multiple clouds? And we're seeing that nicely now start to emerge as well. From that same developer summit, Jonathan Barry and Alvaro from Goliath, which is a startup, basically were presenting their code. They've got a public SDK that's available. All the stuff's up available in GitHub, or I wouldn't be putting it on my slides. Okay. And they gave a talk at the same SDK about how it's connecting to clouds, and it's using the standard protocols that you saw in that first slide. And they've got some of their own shims in their SDK and are talking to, Amazon and Google and IBM, so it's possible. They're demonstrating it being happening today. They're also doing work on fleet provisioning and using secure authentication for the tokens and best practices for setting up the crypto keys. So they're trying to make that part easy for everyone too. So with the ecosystem that's emerging around Zephyr as well as Zephyr itself, I think we're starting to get to something that we can actually securely use for these devices as they emerge. So I guess, the summary from security is we've been there, we've been doing it, we're going to continue doing it. We are CNA, we have that best practices badge, and we're leveraging automation wherever we can. We've improved our vulnerability management, and we're now supporting a Sbomb Generation. So as people learn of best practices, please come talk to us. We want to try to adopt it in this project. So a couple final thoughts. If you're using resource-constrained endpoints, all these things can be vulnerable over time. People learn about security software. They see there's a potential vulnerability. There's a big business right now from the crime perspective working on these things. And, we need to basically be able to adapt. In some cases in these endpoints here, the solution is going to be throw out the device. Okay, a light bulb. You're not going to spend a lot of time on, something that costs less than $1, right? On the other hand, if something is sitting in a tree way up where, or sitting in a wind farm turbine, you may want to actually, adjust it and, do an update for it. We're going to need to be able to do that capability. And each time around, it's going to be a risk to risk trade-off. So active monitoring and, quite frankly, having the project monitor this shares the load amongst all our members, as well as the wider community as well. And we're very fortunate that for the Zephyr project, we have various members that are committed to these goals. So final thoughts, just if you are thinking about resource-constrained devices, take a look at Zephyr and see if it's going to catch what you're looking for. And if it doesn't, please reach out to me and let me know so that we can start to figure out what we're missing in our project.